The people who built today's most powerful AI models are now saying the old playbook is done. Not critics, not skeptics, the actual architects of the system. The co-founder of OpenAI said the age of scaling is over. The Turing Award winner, who led AI at Meta, called large language models a dead end. These are not random opinions. These are warnings from inside the machine. In today's breakdown, we discuss why the AI race is no longer being won in a lab. Why the most powerful force in artificial intelligence right now is not a model, not an algorithm, and not a dataset. Why every major software company on Earth is suddenly spending billions on hardware. And why the future of AI runs through a single island that most people never think about. Let's get into it. The wall nobody saw coming. For the last 5 years, AI ran on a beautifully simple recipe. Take a model, make it bigger, feed it more data, give it more computing power. Repeat. Every time you did that, the AI got dramatically smarter. It felt like a law of nature. You pour in more, you get more out. This is what researchers call scaling laws. And for a while, they worked like magic. OpenAI went from GPT-3 to GPT-4, and the leap felt almost impossible. Companies raced to collect more data, train larger models, and rent more GPU power from Nvidia. Software was the engine, data was the fuel, and it seemed like the road ahead was endless. But then, something quietly broke. Ilya Sutskever co-founded OpenAI. He helped build GPT-3 and GPT-4. If anyone understood how this system worked, it was him. And recently, he said something that should have made headlines everywhere. He described the years from 2020 to 2025 as the age of scaling, and then said it is over. His exact words: would everything really be that different if you had 100 times more data? I don't think that's true. That is not a small admission. That is the architect of the system saying the system has limits. The reason is simple but uncomfortable. The internet ran out. Everything these AI models know came from the internet. Every article, every forum post, every Wikipedia page. Sutskever himself described data as the fossil fuel of AI. And just like fossil fuels, there is only so much of it. The high-quality human text on the internet has essentially been consumed. What is left is increasingly AI-generated content, which creates a loop of diminishing returns. You are training AI on AI output. The signal gets weaker every cycle. Software alone can no longer drive progress. Something else has to take over. The bottleneck did not disappear. It just moved from the data center to the chip factory. And that move changed everything. Hardware becomes the weapon. When the fuel runs dry, you stop racing to find more fuel. You start building a better engine. That is exactly what happened in AI. And the engine is silicon. Think of it this way. Software is the recipe. Hardware is the kitchen. For years, everyone obsessed over perfecting the recipe. Better algorithms, smarter architectures, more parameters. Now, they are realizing the kitchen itself is the constraint. It is too slow, too expensive, and consuming too much power to keep up with what AI needs to do next. The GPU, which Nvidia turned into the dominant AI chip, was originally designed for video games. It is powerful, yes, but it was not built for running AI models continuously at massive scale. As AI inference, actually using models in the real world, not just training them, became the primary workload, the GPU started showing its limits. It is like using a Formula One car to deliver packages. Impressive, but not built for that job. According to industry analysts, in 2025, power replaced raw computing speed as the primary bottleneck in AI progress. The key metric stopped being how many calculations a chip can perform per second. It became how many useful AI outputs, what the industry calls tokens, you can generate per unit of energy. Tokens per watt. That is the new scoreboard, and it is a hardware scoreboard, not a software one. This is the moment hardware stopped being a commodity and became a competitive weapon. The custom silicon race. Once the industry understood this, the response was immediate and expensive. Every major tech company started building their own chips, not buying them, building them. Google was first. They have been developing their own chips, called TPUs, tensor processing units. since 2015, a decade of quiet investment that most people ignored. The latest generation delivers roughly 10 times the performance of its predecessor and 30 times the energy efficiency of a 2018 chip. Anthropic, the company behind Claude, recently signed a deal to access over 1 million of these TPUs, a deal worth tens of billions of dollars. But Google was not alone for long. Amazon built Trainium for AI training. Microsoft built Maya 200, running on TSMC's 3-nanometer process, claiming 30% better performance per dollar than their existing fleet. Meta built their own inference chip called MTIA, and OpenAI, a company that started as a pure software research lab, partnered with Broadcom to build custom accelerators targeting 10 gigawatts of capacity, with production beginning in 2026. Read that list again. Google, Amazon, Microsoft, Meta, OpenAI. These are software companies. They build models, platforms, and productivity tools, and every single one of them is now in the chip business. That does not happen by accident. That happens when hardware becomes the deciding factor. The numbers confirm it. Per research firm TrendForce, custom chip shipments from cloud providers are projected to grow 44% in 2026. General-purpose GPU shipments, 16%. The gap between those two numbers is the gap between the old era and the new one. Nvidia still dominates, holding roughly 70% of the AI chip market. Their revenue reached $215 billion in fiscal year 2026, up 65% from the year before. But even Nvidia knows what is coming. The era of one chip for everything is ending. The era of purpose-built silicon, designed specifically for AI, has already begun. The constraint that changes everything. But there is a dimension to this hardware shift that goes beyond chips, one that most people are not talking about, and it is arguably the most important one: power. The International Energy Agency published a report in April 2025 with a number that should stop you cold. Global electricity consumption from data centers is projected to roughly double by 2030, rising from around 415 terawatt-hours today to nearly 945. To put that in perspective, that is roughly equivalent to the entire electricity consumption of Japan, added to the global grid, just for AI and data centers. In the United States specifically, data centers are on course to account for almost half of all new electricity demand between now and 2030. Jensen Huang, Nvidia's CEO, now describes data centers not as server rooms, but as factories, AI factories. Their raw material is electricity. Their product is intelligence, measured in tokens per second. His formula is blunt. Revenue equals tokens per watt, multiplied by available gigawatts. In other words, the company that generates the most intelligence per unit of power at the largest scale wins. This is why tech companies are now signing nuclear energy deals. This is why power grid capacity has become a strategic asset. The race is no longer just about who writes the best algorithm. It is about who can secure the most megawatts. Software used to scale on a server. Now it scales on a power plant. And all of this, the chips, the energy, the billions being spent, it all leads back to one place. The one island that controls it all. And here's where the hardware story becomes something much bigger than a technology story. Every chip we just talked about, Google's TPUs, Amazon's Trainium, Microsoft's Maya, Nvidia's Blackwell, all of them run through one place, one island, Taiwan. More specifically, one company on that island, TSMC. TSMC manufactures over 90% of the world's most advanced semiconductors. And according to research by Ake Freeman at the Hoover Institution, TSMC produces roughly 99% of the chips used to train frontier AI models. Think about what that means. The entire global AI industry, every model you have ever used, every chip that powers it, depends on a single company, in a single location, that sits in one of the most geopolitically contested regions on Earth. Bloomberg Economics estimated that a serious disruption to Taiwan's chip supply would cost the global economy around $5 trillion in the first year alone. This is why the United States passed the CHIPS Act, spending billions to bring semiconductor manufacturing back to American soil. TSMC is now building factories in Arizona. But building a world-class chip fab takes years and costs tens of billions of dollars. The dependency is not going away anytime soon, and China knows this better than anyone. The US has restricted China's access to advanced chips since 2022, tightening the rules in 2023 and again in 2024. China is pouring resources into building its own semiconductor industry. The competition over AI has quietly become a competition over silicon. Hardware is now a national security issue. But China has another weapon that most people are not talking about. The raw materials inside every AI chip: gallium, germanium, tungsten, rare earth elements. China controls the supply of almost all of them. In December 2024, China banned exports of gallium and germanium directly to the United States. Antimony, another material used in semiconductors, went from $1,400 per ton to over $51,000 per ton after China restricted it. These are not market fluctuations. This is a country using the physical ingredients of AI chips as a geopolitical lever. You cannot write code to fix that. What started as a technology shift is now a geopolitical one. The hardware era is not just changing who wins in AI. It is changing how nations compete. What this all means. So step back for a moment. Look at what we just covered. The software scaling era hit a wall because data is finite. The industry responded by making hardware the new frontier. Every major tech company is now building custom chips. Energy consumption is doubling, and the physical supply chain for all of it runs through a single island that the entire world is watching nervously. This is not a story about one company or one chip. It is a story about where power lives in the AI era. And power, in every sense of that word, has moved into the physical world. The combined AI hardware investment from Amazon, Microsoft, Google, and Meta is projected at between $600 and $700 billion in 2026 alone, and it is already getting more expensive. Microsoft recently revealed that $25 billion of its 2026 AI budget went purely to higher chip and memory prices. Not to new capabilities, not to better models, just to cover the rising cost of hardware. McKinsey estimates total global investment in AI-capable infrastructure will reach $6.7 trillion by 2030. We spent decades believing the most powerful thing in AI was an idea, a breakthrough, a better algorithm written by a brilliant team in a lab somewhere. But the era we are entering says something different. The most powerful thing in AI is now a factory, a chip, a megawatt. And whoever controls those things controls what the future of intelligence looks like for all of us. If this changed how you see the AI race, hit the like button. It genuinely helps this channel reach more people. Subscribe for more breakdowns on the stories that actually matter in AI and tech. And drop a comment below. If hardware is now the real power in AI, does that mean the next Google or OpenAI will not be a software company at all? Thanks for watching.